We'd like to thank the Cloud Native Computing Foundation for sponsoring our podcast from CloudNativeCon in Seattle. Inspired by internet-scale computing, the Cloud Native Computing Foundation advances the development of cloud-native technology and services by creating a new set of common container technologies informed by technical merit and end-user value. You can learn more about the Cloud Native Computing Foundation at cncf.io. Hey, it's Alex Williams, the new stag here at KubeCon, Cloud Native Day in Seattle, Washington. And we're just getting started with the conference, and this place is packed. I mean, it is like wall-to-wall people, and I'm here now with Ben Sigelman of Lightstep. Ben, great to have you here.
Thanks. Yeah, it's great to be here. Yeah.
This is quite an event.
Yeah.
I mean, it is packed.
It's really packed. I actually was talking to someone that I kind of like that it's a little oversubscribed. It makes it feel more energetic, you know.
This is probably a few less people than you have at your meetups, right?
Yeah, usually we have, we try to get those in Candlestick Park or Stadium Show or something, but occasionally we have to go for a ballroom or something.
So Ben, I was just talking with you a little bit about your own background, and really the theme for our discussion here, I'd like to talk about OpenTracing and how that relates to Kubernetes and your own company, Lightstep. So, first of all, tell us a little bit about your background, and you worked at Google for 2003 to 2012, and tell us about your kind of your history with tracing, and what is OpenTracing?
Sure. So yeah, I was at Google for a while, more than I might recommend to those listeners out there. I was traveling around the country and just couldn't kick the habit of staying there. But for the first couple of years, I was just getting my feet wet. I was frankly very young and inexperienced, and I eventually realized there was a ton of pain at the company around visibility into distributed systems, which at the time were quite similar to what you see deployed now in these containerized environments. Lots of small services with very narrow, focused charters. And
what were some of the huge pain points that you would get to when you were developing in a distributed infrastructure back in those days?
Yeah, I mean, the biggest one then is the same one I think is the biggest one now in microservice architectures, and it's the one that people I think are frankly embarrassed to talk about, which is that they just literally do not know what's happening at a very basic level in transactions.
What's happening? In the events?
So it's feasible to say, okay, let's look at how many requests this process is processing per second or whatever. That's no problem. But if you want to actually tell the story of how an actual transaction goes from an end user on a mobile or web client through a distributed system and back again to that user, that is really, really difficult to do using off-the-shelf time series monitoring and log aggregation. So difficult that it just doesn't happen. So most of the companies that I'm aware of that have expressed interest in tracing, which is frankly a lot of companies at this point, they're trying to address that basic need, that they literally do not know what's happening in their own systems, which is a profound problem, and one that is almost inevitable if you try and apply single process oriented tools to distributed systems with heavily decoupled microservices. So that's the main thing we were dealing with. We wrote a paper about Dappler, which is a system I built at Google that emphasized a bunch of really interesting critical path analysis and aggregate analysis of traces, and trying to come up with equivalence classes of distributed call graphs and blah 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 blah. And that was definitely real and was valuable. But actually, the most valuable thing was you'd look at a trace of something that took too long. You'd say, oh gosh, it's doing these 10 operations in serial which don't depend on each other. They should be done in parallel, which is an extremely easy thing to see if you actually have the data. And if you don't, it's impossible. And so that was the fundamental thing that most people needed, and frankly, the fundamental thing most people need now is just basic coverage of a distributed system.
Now, those problems would manifest themselves in what kinds of ways? Would that manifest in an end user issue? Would it manifest itself in terms of just inefficiencies, on the distributed, environment itself?
The answer is yes.
Yeah.
And many other things as well. We found that it was also quite challenging to contextualize failures at the lowest level of infrastructure. You often see in modern systems, you'll see these diamond-shaped graphs where a front end will call some middle tier service, which then calls some database layer or Cassandra or something like that, where you have many different consumers of this common thing at the bottom of the stack. And the bottom thing at the stack will have some error, and you have no idea where that request actually came from or what contextualizes it. And so that's a really pernicious thing. Oftentimes where errors are most important to you at these sort of workhorse layers, databases, that sort of thing, it's difficult to contextualize things without some sense of where the data came from. And so that was in addition to the bread and butter of user-facing latency and just general system awareness. Those are the things that we would often see people talking about.
So you developed Dappler at Google,
yep.
And now you're behind the OpenTracing diagnostic tool. What's the difference between those two?
Yeah, well, I think the biggest one is that, maybe the biggest one is that Dappler was never open sourced or anything like that. Dappler is a proprietary technology developed inside Google that we happen to write a white paper about.
Right.
And the closest parallel in the open source world is certainly Zipkin, which was designed very carefully to model the description of the system we had in the paper, and that was open sourced by Twitter and is now maintained by a very healthy open source project run by Adrian Cole, who's at Pivotal now, and the Zipkin project.
Or Zipkin, yeah.
So Zipkin and Dappler are kissing cousins in terms of their design. OpenTracing is in some ways a different type of project. OpenTracing and Zipkin are actually completely compatible and I would say complementary. OpenTracing is only trying to address the abstraction of instrumenting source code. My experience at Google developing Dappler was quite different than my experience working on similar technology in the larger ecosystem. Google had a monolithic source repository, still has a monolithic source repository. So if you made instrumentation changes to Google's RPC system and Google's control flow system, you were able to get coverage of their entire distributed system. Outside of Google, it's not like that at all. If you add instrumentation to pick your favorite open source project, all you've done is instrument that one project. You haven't instrumented the rest of someone's stack. And so it's this incredible death by 1,000 cuts if you're trying to get tracing deployed at a modern organization that's using many different frameworks from many different open source projects and so on and so forth. So the point of OpenTracing was to come up with a lingua franca for describing the flow of control throughout distributed systems. This is actually the pain point for deploying distributed tracing. It's not standing up a tracing system. It's not the UIs. It's not any of that stuff. It's just getting instrumentation established. And OpenTracing is a standard that aids in the process of building the instrumentation. So you can't run OpenTracing. It's not in and of itself a system. It's a vendor-neutral API that plugs into Zipkin. It plugs into Jaeger, which Uber just announced last week, which is their tracing system. It plugs into a number of commercial solutions and a number of smaller open source tracing systems as well. But you can think of it more like you'd think of HTTP or something like that, where it's this common standard that you can program against and get interoperability for this type of observability system.
And that's really the heart of it, is like that standardization.
Yes, and the constituencies that care about it are certainly commercial entities that have big distributed systems. They have this pain point of instrumentation. Tracing systems like Zipkin, or Jaeger or what have you, that want to have as much coverage at the instrumentation layer as they can get, and by supporting OpenTracing they can get a lot just in one fell swoop. And the maintainers of open source libraries, like the maintainers of GRPC or the maintainers of DropWizard or whatever microservice framework you're interested in, those sorts of project owners are interested in OpenTracing because it allows them to interoperate with every supported tracing system with one piece with one commit, essentially, by instrumenting one time with OpenTracing. And so it's a standard that benefits those three constituencies.
So OpenTracing has been adopted by the Cloud Native Computing Foundation, and what is its role in that context?
Well, I think that, to a certain extent, you should probably ask the cloud native folks, but my understanding from being on the TOC calls and so on, I think the excitement they had about OpenTracing was really that they aim, and all of the keynotes this morning really underlined this, I think they aim for vendor neutrality and portability and extensibility, and those are three things that OpenTracing gives you. It's also operating in a space that's very, very tightly coupled to, frankly, the downside of moving to cloud native. If you're using a monolithic approach to building your application, you don't have this problem that I'm describing. But as soon as you move to using Kubernetes in earnest or similar, orchestration systems in earnest, you are blindsided by this visibility problem. And so it's complementary in that it helps people move more quickly into that sort of deployment model. And of course, in as much as OpenTracing needs users, OpenTracing benefits from that same migration. So it's a mutualistic relationship between OpenTracing and the other things that CNCF is onboarding into their foundation.
So tell us about Lightstep, and that's the company you founded.
Yeah, so I'm happy to talk about it. Lightstep is, it supports OpenTracing. It's in many ways something that is informed by our experiences. Much of the core team came from Google. It's informed by our experiences building systems like Dappler and other monitoring systems and the pain points that we were addressing at Google. I think that we've attempted to do our best to not overfit to Google's experience. Things like that monolithic source repository at Google are really not representative of the larger ecosystem. And one of the things that is troublesome for me about most tracing systems is that they actually often directly cite Dappler as an influence. Honestly, Dappler was not the right thing for the rest of the world. It was debatably not the right thing for Google, and it was built in 2005. And so I think with Lightstep, we're attempting to build something that we think addresses the same type of pain point, but in a way that's more representative of modern stacks, the way that modern companies prioritize things and so on.
Now, I'm looking at the story that we wrote about Lightstep, and you're quoted in it, and you're saying, and I'm thinking about, where does Lightstep go? Where, what is its direction? And you'd say, I'd like to see a story for OpenTracing in that environment, which will require standardization beyond just a level of APIs. Will involve some standardization about the way the tracing data looks on the wire and is formatted on the wire. I'm eager to pursue conversations with people from those communities. What is it about the needing to go beyond the level of the APIs? It's so fundamental.
That's actually quite relevant to this conference, actually, and Kubernetes and so on. I think one of the dreams everyone has when they're trying to deploy something like this is to make no source code modification at all, and to just integrate via something like something that runs within a Kubernetes pod, or they have this concept of a daemon set, which allows you to have things like FluentD or Linkerd or Envoy or something along those lines running on every VM that has pods installed and so on. If it's possible to integrate OpenTracing at that layer, you can deploy distributed tracing without source code modification, which is a really important thing, especially when you want to support software in environments where recompiles and redeploys are not happening every day. I think a lot of the bleeding edge adopters do actually have a continuous deployment model where, most of the software they run in production is actually written in-house and so on. But if you move into more established enterprise environments, much of the software that they run is from vendors, and they redeploy it infrequently and recompile it never. And if you want to operate in that environment, it's necessary to have some kind of shim that comes in at the container or VM level. And OpenTracing to date has focused on the API, which has been the most urgent priority. But as OpenTracing gets pushed up market, which I think I'm starting to have those conversations with people on an inbound basis, I think there's a lot of desire to have the standardization of wire formats that would allow something that intercepts HTTP to automatically trace an arbitrary application. So it's these sorts of wire format standards would allow a large enterprise to adopt tracing without tying themselves to a specific vendor or to a specific even tracing methodology by integrating via container proxies and so on. So.
It seems like what we're also moving to is, when you're talking about the wire, is just being able to understand the data a lot better, right?
Yep, absolutely.
And being able to almost kind of develop that metadata so you can do the analyses, that would allow you to move beyond than the API itself.
Yeah, that's exactly right. And I mean, I would underline that by saying the technology that runs within the application itself that we developed for Dappler, its largest commercial application at Google, and I hope I'm allowed to say this, but I don't know, it's been many years since I worked there, is probably actually not having anything to do with monitoring in the traditional sense of reliability. It's that code path is used to pass contextual information about the top level owner of a request, whether that be Gmail or Calendar or Web Search or Spreadsheets or whatever Google product you're using. That information is passed literally 15 to 25 layers of distributed infrastructure down until it gets down to a disk or something like that. And the individual disk writes are apportioned by that user, Gmail, Web Search, Calendar, etc. And that apportioning allows those underlying storage systems to do real-time pushback and throttling of global quotas for these various groups within Google, where Google can manage its multi-billion-dollar spend on that sort of technology with very fine granularity, despite the fact that those lowest layers are totally shared infrastructure. So they have no waste by over-provisioning every individual user. They have one big pool, and it's throttled at an extremely fine-grained layer via a feedback loop that's powered by this sort of tracing technology. Not for latency analysis, but actually reusing that code path to do propagation of information. And OpenTracing supports that via this mechanism called baggage, which is the idea that there's data that flows along with the request transparently. And this is like a really powerful, I think, a paradigm shift in a sense, where you have data that's transparently flowing through an application and being used to tie, key value information from the top of the stack to semantics at the bottom of the stack. And that's a really powerful shift, I think, that we're going to see a lot more of as people move to more shared infrastructures. So
Kubernetes is still very nascent, and OpenTracing is very nascent.
Yes.
What are the projects in the immediate future that you're going to be working on kind of in that context?
Well, I think we already talked about one of them, in that I'm having conversations with a number of people about developing better standards for interoperability of observability tools, including tracing tools in a containerized environment. That's a big piece of it. We're also working on a number of integrations with technologies that work well in that type of environment, like GRPC, which I had mentioned earlier.
Yeah, GRPC is interesting.
Yeah, in order to get better.
Which goes beyond the API.
Exactly. Yeah. Which is and GRPC and OpenTracing already integrate well, and I think we're looking to proliferate that sort of thing into similar projects and similar technologies.
For our listeners out there who may not be familiar with GRPC.
What's GRPC?
Yeah,
GRPC is an open sourced RPC framework. So an RPC framework is something that allows a process to make a remote method call. It's not dissimilar from things like Thrift or Avro or a number of other projects that have been spun out in the last decade. I think GRPC has a ton of momentum. If you just look at commit logs and GitHub stars and so on, it's just on this incredible trajectory. It's also, Google's migrating all of its internal RPCs. They make 10 billion RPCs a second right now. They're migrating all of that to gRPC over the course of the next couple of years as well. So it's an important project. The benefit of it is mainly not around actually RPC, it's around tooling. So it allows you to do things like service discovery, client-side load balancing, tracing, monitoring, in a way that's completely transparent to the user. And that uniformity as an API layer to plug in is what makes RPC systems so appealing. It's not actually the RPC. That part's actually pretty easy. You just make an HTTP call, but it's all the tooling you can build around it and integrations.
So, to end the interview, what's next for Lightstep?
For Lightstep, well, we don't really talk a lot about Lightstep so far. It's not so much that we're stealth. I think it's just that we've frankly been somewhat surprised and overwhelmed with the amount of inbound interest, but I think we'll have some success stories to talk about in the next couple of quarters, and we'll be GA next year sometime, which will be exciting. And I think our goal is to change the way people think about monitoring of distributed systems, and we'll see how far we get with that.
Great. Well, congratulations on starting the company and getting the OpenTracing project. It's getting a lot of interest. We see a lot of interest on our site, the news tag. So let's keep in touch.
Yeah, thank you.
Thank you.
Yeah.
We'd like to thank the Cloud Native Computing Foundation for sponsoring our podcast from CloudNativeCon in Seattle. Inspired by internet-scale computing, the Cloud Native Computing Foundation advances the development of cloud-native technology and services by creating a new set of common container technologies informed by technical merit and end-user value. You can learn more about the Cloud Native Computing Foundation at cncf.io.